Hi there. This video is going to be talking about angles and triangles and talking about the theorems. It's a big word for theories that people have developed over time with regards to triangles. And yeah, let's just start right here and get right into it. And maybe you know some of this stuff and you're welcome to skip forward if you understand this already. But if you're identifying the side of a polygon, in this case we're talking about a triangle, it's a kind of polygon, okay? A polygon is something with many sides, 3 or more sides to be exact. We're focusing on triangles today, which have 3 sides, as you can see. If you're identifying one side of a triangle, we could say 2 different things. For example, if we're talking about this side right there, we could call it side AC, or we could look at this big B right here, this angle B, and often people label them with a little b there. So the big B is the angle right here, and the little b would be the side across from that, okay? Just like this side here would be little c, the big angle C right there. And of course, this angle capital A right here, this angle A, would be little a out over here. So for this side, once again, we could call it side B, as in a small case B, or side AC. All right, let's move to the next part. If we were talking about angles in a polygon, or in this case a triangle, we could just call this angle A. Okay? That would be one way of doing it. Another way to do it would be to think about what lines make this angle. Well, you start here, you draw this line, so from C to A and then from A to B. So you could say angle CAB. That would also be talking about that angle right there. And you just focus in on the middle letter, which is the letter A, okay? Angle A. So you could call it angle A, angle CAB. Can you see another way to call it with 3 letters? You could say angle BAC. As long as the A is in the middle, you're good to go. Okay, so that's angles in a polygon and how to identify them. Now let's move on. Here we have, I'll choose a different color here, I'll choose blue. If we were to choose one side of the triangle and we wanted to label it, let's just pick this side right here. We'll call it JA. There, that was easy. We just talked about that on the previous page. One interior angle of the triangle, let's just talk about this A up here. So we could call it JAM, as in jam, or we could just call it angle A, capital A. That's probably the quickest way to do it. One exterior angle. By the way, interior means inside the triangle. Okay, so this is an interior angle. An exterior angle would be the outside of the triangle, like this angle right here. Okay, that is an exterior angle to this triangle. There's another exterior angle right here. Okay, and the way you make an exterior angle is you can extend one of the sides, either this side or this side, and the angle that the line that you've made with one of the sides is what we call an exterior angle. So this here we don't really call an exterior angle. You take the side that you've extended, okay, so this side here, and then you find the angle that meets up with one of the sides of the polygon, in this case triangle. So this is an exterior angle. We could call this one, we can't just call it angle J. Okay, that would be too confusing. We're going to have to call it 3 letters. So an exterior angle, we'll call it angle HJM. I don't know if I can squeeze that in very well here. HJM. Hopefully that makes sense. If I just called it angle J, that would have been confusing. We wouldn't have known if you're talking about this angle here or this angle here. It would have been confusing. So HJM or MJH if you like that better. Okay, supplementary angles, if you've forgotten, are angles that add up to make 180 degrees. Okay, 2 angles that make a straight line are called supplementary angles. So this angle M right here, or angle AMF if we want to call it that, that angle and angle AMJ, so that angle, the blue angle right here, plus this angle right here will make a straight line. And those are called supplementary angles. They are 180 degrees. A straight line is 180 degrees. You probably already knew that. So a pair of supplementary angles, it's a bit difficult to write it all in with this pen. I will try. I'll just say angle AMF and angle AMJ. Okay? Those two angles make supplementary angles. As far as complementary angles, I'm going to erase what I've written down so far so that I have more room. A pair of complementary angles, those are angles that add up to 90 degrees, not 180 degrees. So here's a 90 degree angle right here, and I want two angles. See, this is just an angle MGD is a 90 degree angle, but that's just one angle. Complementary angles are when we have two or more angles, and generally we just talk about it as two angles that add up to 90 degrees. So DGB, so that would be angle DGB, and angle BGF. BGF. Those make two complementary angles right there. Okay? You can always push pause if you want that to stay there. I just deleted it. An acute angle is an angle less than 90 degrees, okay? An angle less than 90 degrees. So here's an acute angle, for example, BGF. Okay, angle BGF is less than, here's a less than sign, 90 degrees. That's confusing. This looks like a less than sign. This also does. Yikes. This is actually supposed to be a less than sign here. Boy, I shouldn't do that to my students. An obtuse angle is an angle bigger than 90 degrees. Okay, so look for an angle somewhere in here that's bigger than 90 degrees. I once again look to this angle right here. AMF is bigger than 90 degrees. It's greater than 90 degrees. Do you see any more? Well, this one over here. In fact, we will learn very shortly that this angle and this angle are actually identical because they're called opposite angles when they're across, like when they're across from this so-called X from each other. So JMP is also an angle that's obtuse. Okay, let's move on. Interior angles, once again, are these angles right here. Okay, these are interior angles. They could be acute or obtuse, but they're all interior. They're on the inside. Okay, I guess that's all we need to say about that. Exterior angles are angles on the outside, but be careful, it's not the 180 degrees part that you see here. It's this part right there, it's this part right there, and it's this part right here. Okay, these three angles are exterior angles. Okay, and we're going to talk about this soon, that these three angles for a triangle, the three interior angles of a triangle, add up always to 180 degrees, and any polygon, the exterior angles will always add up to 360 degrees. I have another video on that, on exterior angles specifically, in case you want more information on that. Okay, let's keep moving. So, here it is. The sum of the exterior angles of a triangle is 360 degrees. That's exactly what I just said. Okay? The interior angles of a triangle are 180 degrees. Again, I just said that. If you had to prove it, you could look, and there's a video that I have on a transversal with two parallel lines. These are called transversals, and these two lines are parallel right here. This one and this one are parallel. And that gives us some information. It means that A and D are the same. A and D are the same. Angle E and angle C here, they are the same. And angle B is, something else. But because we know a triangle adds up to 180 degrees, Well, we also know a straight line is also 180 degrees. And how could we prove it? How could we prove it looking at this picture here? Well, okay, here's a straight line. So we know these three angles add up to 180 degrees. And the cool thing is A and D are the same. These two are the same. And angle E and C are the same. And angle B is obviously angle B. So if you were to go D plus B plus E, we know it adds up to 180. That means these three angles also have to add up to 180 degrees. Okay, and ITT, the isosceles triangle theorem. An isosceles triangle is a triangle where two sides are the same length. If you take two sticks and you put them together and they form a point like this, there's something interesting about these two angles. They will be identical because the sticks, because they're the same length, they will lean and they have to meet each other so that these two angles on the inside, these two interior angles, will be identical. They will be the same. And that's what this is trying to say right there. And AB is also the length of AC. We already saw that there. And it's symbolized by these lines right here. Okay? The ETT, the Equilateral Triangle Theorem. Now this triangle doesn't look terribly equilateral to me, but I'm going to go with it. Let's just pretend all of these sides are exactly the same length, okay? If all three sides are the same length, that means all three angles are going to be identical. So can you tell me right now, if you want to push pause, what would all of these angles be? If a triangle adds up to 180 degrees, and if every angle is the same, and there's three of them, how big would each angle be? You can push pause if you like. You should come up with 60 degrees, okay? 180 divided by 3 is 60. So it doesn't say that here, but equilateral triangles have an angle of 60 degrees. And it doesn't matter how long the sides are. If they're all the same, as long as the sides are the same, you're going to have a 60-degree angle on the inside. Okay, the EAT theorem, exterior angles theorem. This one's kind of interesting. The sum of the two interior angles opposite an exterior angle is always equal to that exterior angle. So in other words, this angle here is always the same as this angle plus this angle added up. Okay? This angle and this angle, even though they're different, there, I'm putting 3 lines there and 2 lines here. All of these angles are different, but they will add up to, these will be identical. Okay? Why is that? Well, this angle plus this angle have to add up to 180 degrees because it's a straight line. And that means, if you think about this angle in here, that means this angle plus these two also have to add up to 180 degrees. So these two have to be the same as this one. I don't know, I'll say it one more time. This angle plus these two have to add up to 180 degrees because it's a triangle. This same angle plus this angle also has to add up to 180 degrees. So that means the things with the two circles have to be equal to each other. They have to. Next one. These are just some quick examples. Let's go through them really fast together. Okay. There is a previous video that would be on opposite angles. And opposite angles are when you make an X, and if you look across 72 and you look across and you see the M there, that also is 72. Okay? So M would equal 72 degrees as well. The Z there, how would you come up with that? Well, just think, what's 180, because it's a straight line, minus 72. So what's 180 minus 72? You can do it in your head. Whoops, it should be 80. 180 minus 72. So Z would equal 180 minus 72 is 100. Let's check it out. So 180 minus 72 is 108. Okay? And we have more. We've got 72 and 44 and this letter P here, this angle P. So remember, a triangle always adds up to 180 degrees. So 44 and 72, if we take away from 180 minus 72 minus 44 should give us P, and P is 64. And if P is 64, well, Y would be something along a straight line. So 180 minus 64 should give us Y. Okay, so 180 minus 64 will give us 116. So Y is 116 degrees. And lastly, N and Y have to be identical because they are called opposite angles. Okay, so that's also going to be 116. All right, let's quickly do this one. Remember, isosceles triangle means these two sides are the same length. That means these two angles are also the same. Okay. If we wanted to find F, we would just say 180 minus 35. Okay, so 180 minus 35 is equal to 145 degrees. And lastly, well, 180 minus 70, because we have 35 and 35, should give us E. So 180 minus 70 is 110. This should be 110. Okay, let's go to the next page. Here is a question. Okay, again, we know that there's a few options here. 180 minus these two will give us Y. Okay, so 180 minus 29 minus 52, that will give us, okay, that's 99 right here. 99 degrees. And 180, which is a straight line, minus 29 should give us X. So 180 minus 29 should give us X, which is 151. And by the way, there was that theorem earlier that said that this angle should be the same as these two angles added up. Well, let's see. What's 99 plus 52? 151. Look at that. These two really are the same. The exterior angle and these two across are identical. Okay. Once again, 115 degrees. If we go 180 minus 115, 180 minus 115, I'll move this over, is equal to 65. Okay, and this one's quick. Because this is an isosceles triangle, these two sides are the same. This also has to be 65. Okay, let's keep going. There's probably a couple more here. Here we have two pictures, and it's trying to get us to figure out what x is. It says 4x plus 1 plus g would make 90 degrees, and this one's 2x plus 5 plus g also makes 90 degrees. Well, if g is the same, it must be, that means these two have to be identical too. That means 2x plus 5, I just wrote that down from here, should equal 4x plus 1. Okay, and I'll do some quick algebra here. I'm going to bring the 2x over to the 4x. I'm going to minus 2x from both sides. Okay, that gets rid of it. So we'd have 2x, and I'm going to subtract the 1 from this side and this side. So that gives us 4. So finally, x is equal to, divide both sides by 2. So x is equal to 2. We now know that x is equal to 2 here. In case that was what your teacher wanted you to solve, find out what x is here. Sometimes they do that to you in these kinds of questions. They give you sort of an algebraic equation. And that's a whole nother video. If you don't know how to solve an algebraic equation, definitely something you should check out. I have lots of videos on how to solve algebraic equations in algebra. Okay, if you get a situation like this, you have a 50 degrees up here, you have two legs or two sides of the triangle that are the same, it's an isosceles. We know B and C are the same. And 180 minus 50 is 130, right? But we have to share the 130 between B and C. They have to be shared. So what's half of 130? It's about 65 degrees. And this angle and this angle are opposite angles, so D is also 65 degrees. And this angle and this angle, they add up to 180 degrees. So 180 minus 65, 180 minus 65 is equal to 115. So that means A has to be 115 degrees. Okay, let's keep going because I think there's two more questions and then we're done. If I recall. Okay, we're not quite. There's three more. 32 degrees. Okay, so this is 32. These are two parallel lines. So we know from earlier videos that this angle and this angle are the same. They're going to be the exact same angle. Alternate interior angles, they are called. So this is going to be 32 degrees. So we have that much. And let's see, what else do we need to know? These three angles here, they are supplementary, which means they add up to 180. So if you go 180 minus 70 minus 32, let's do that right here. 180 minus 70 minus 32, we come up with 78 right here. 78 degrees. Okay, so we know this is 32, this is 78, so we should be able to come up with A. So if we take 180 minus the other interior angles, so 180, because it's a triangle, minus 32, minus 78, we come up with 70 right here. There we go. All right, yeah, there's other ways to do this question, but that's the way I did it. Let's keep moving. Sorry, it's a mess. It's also hard to read that. For this question here, there's a few different options, okay? We know this angle is an exterior angle of this triangle, and these two have to add up to the same thing. So 90 plus something should equal 125. So that would be 35. Let's see. 90 plus 35 is 125. There's other ways to do it. Let's see. D. Okay. D and this angle here have to add up to 180. So that means 125 and this angle here are on the same line. So 180 minus 125. So 180 minus 125 is 55. So we know this is 55. That means D is also 55. And let's just check and see if this all works out. What's 55 plus 35? That is 90, and 90 plus this 90-degree symbol here is 180. So we know things have been done correctly. Okay, here's a question. 2x plus 5 and x plus 10. We're supposed to figure out what x is again. Well, if you remember, two complementary angles add up to 90 degrees. That means we know that 2x plus 5 plus x plus 10 is supposed to equal 90 degrees. Okay, so now let's collect like terms together. So 2x plus x is 3x, and 5 plus 10 is 15. That should equal 90. Now let's just do some algebra really quick. Let's subtract 15 from both sides to get rid of that. So 90 minus 15 is 75. Yes, it is. And divide both sides by 3 to get a final answer. X is 25. We now know that x is 25. If we needed to know this exact angle, we would just sub in the 25 into this. So we would just go 2 times 25 plus 5. That's 50 plus 5. That'd be 55 degrees right there. And then this other angle would be x plus 10. So it'd be 25, instead of x I'm putting 25 plus 10, that's 35 degrees. And by the way, these two angles should add up to make 90 degrees. Do they? Yes, they do. Hooray. Okay, last two questions, I promise. These two angles, we know, added up should make x. So that suddenly tells us that x will equal these two angles added up, 120 degrees. That was quick. We could have done it slower. We could have taken 180 minus 120. That gives us 60 degrees right here. And then 180 minus 60, you're right back to the 120. But we did it a quicker way. This last triangle here, well, we know that all three angles in a triangle add up to 180 degrees. So x plus 3x plus x plus 30 is supposed to equal 180. Let's do some quick algebra. 3x plus x plus x, that's 5x, plus 30 is 180. And let's subtract 30 from both sides. So 5x is equal to 150, and we now know that x is going to be, well, you divide both sides by 5, so that should be 30. X should be 30. So we know that this angle here is 30 degrees. This angle here is 3 times 30, which is 90. And this angle should be 60 degrees, and it is. 30 plus 30 is 60 degrees. There we go. It's a mess, I know, but I just wanted to quickly show you all this stuff. I know it was a long video, but I just had to show you as much as I can really quickly regarding triangles, okay? If you need help on other types of things that I talked about, I will put some links up right above where I'm talking right now. Have a great day, everyone. Good luck out there in the math world.